There you go.
Well, welcome to the April 8th, 2025 session of TAPR and HamSCI technical section. My name is Dave, KB0S, and this week I've been working on TAPR things, organizing speakers for the Dayton Hamvention. And I want to thank Phil for agreeing to speak at the banquet. So, and then Paul Elliott and I will be speaking in the Tapper Forum about similar projects. Paul will talk about his transmit capabilities and some of the other gadgets he makes. And I'll be talking about the support that Tapper is uh, working towards helping the collection of projects that we're doing here, the fact that we have this um, weekly session, and the things we'd like to accomplish as we go forward. So that's about it for me. Lots of phone calls and emails this week, and we're trying to keep things going. So next on the list, we have Nathaniel, W2NAF. Go ahead.
Thanks, Steve. I'm also trying to keep things going at the university. Uh, we have continued working on logistics for trying to get receivers down in Antarctica. So that is, you know, moving along, but we're just kind of in a bureaucratic planning, slow part of it right now. So, but we're working on it. Back to net.
Can I ask which sites you're most interested in?
We are The plan is to put receivers at McMurdo Station, South Pole Station, and Palmer Station.
Oh,
So
all
the
three.
three, yeah, all three of the major US bases, we are we're requesting to send a receiver down this field season to South Pole Station.
Okay.
Now, this season, in a normal year, you're actually allowed to send team members from your team down to do the deployment. Um, and by our team, I mean between like us and really an NJIT. The exact people haven't been identified yet, but they're doing some sort of major reconstruction of or renovation of McMurdo Station right now. So the NSF is limiting deployment. And so this year, the best we can hope for is that we can send a package down and that one of the research associates down there might be able to install it for us. But it
Oh,
would
okay.
have to be a limited effort. We'd have to get everything documented. So right now we're in the part of the project where we fill out every year we have to fill out something called a SIP, a supporting information package, or plan. And that's where we write down everything that we want to have happen. And that includes asking for them to install this thing. And then later in this season, I guess at some point over the summer, they come back to us and say whether or not they're going to do what we asked for in the SIP. So
Okay.
right now we're in that requesting period. And
Very
Dave,
good.
yeah, so far. And so we have this call on Monday afternoons at 2:30 p.m. Eastern. Uh, David McGaw has been coming regularly, and so has Rob Robinette. And then Hyomin from NJIT, he is the lead PI of the project. He has been coming. We have our couple students from the University of Scranton, whom I think most of you don't know. You did meet Rebecca at the HamSCI workshop, and then Christine Zikziski, who's another professor with me, Majid, and Ken Martin, who is one of our volunteers in town. If anyone else is interested in coming, send me an email and I'll be happy to send you an invite to our telecon.
Okay, very good. Next on the list is David, KD0 EAG. Go ahead, David.
Oh, um, hello all. I've been wrestling with WireGuard tunnels and what else? And GPSD BTP setup I'm hoping my good um, timing antenna on the roof is still functioning after all the winds and things. I don't know. I haven't been able to get my clock to connect on that one. But otherwise, some of that stuff's taking far longer than it should, but I really not doing anything very profound. So back to y'all.
Okay. Next on the list, let's go to Bruce, WB4MJG. Go ahead, Bruce.
There we go. Get it unmuted. Nothing much going at all. We're still in process of trying to move houses. I have antenna up at one house and no radios there, and then radios at one house with no antenna. So things are in transit, but enjoying hearing about the meteor scatter. That's something I was aware of, but had never even considered fooling with it. And looks like maybe a good time to think about that. Yeah, other than that, not much at all. Back to net.
Okay. Next on the list is Dave, W6OQ. Go ahead, Dave.
Yes, good evening. So I'm here and here more to learn and see what I can be helpful with. That's it. Thanks.
Okay. And then next on the list is another Dave, Dave Julian, WB9YIG. Go ahead.
Oh, good evening, folks. Just trying to survive from the weather. 3 days without power, 7 inches of rain, and a busted tree that almost fell on the house. So,
Ooh,
yeah, I had to lash it up with a rope to keep it from splitting, and I just got it taken out today. So, blue skies, everything good now. Back to the net.
very good. Let's see. Next on the list is David McGaw in one HAC. Go ahead.
Good evening, everyone. Luckily, the weather's been bleak, but not dangerous around here. Yeah, as Nathaniel mentioned, helping out with the Antarctic plans. One interesting thing, we had someone up at Toolik Lake, where we have in Alaska, that we have equipment, and we're getting interference from something, and it does seem to be external, very loud, closely spaced harmonic street. But he was up there actually to support a sounding rocket project, but was able to have time to help us. Someone that works for or is connected with Steve Kepler and Clemson. Anyway, he took up a sniffing antenna, which I hadn't seen before. It's one of the small loop antennas, and this one's the K180WLA, which I have gotten a copy of. What's unique about it is actually the bias T has a battery in it. It has a lithium battery, so it can actually be powered without plugging it in. And that turned out to be useful. We didn't get everything we wanted out of it, but we were able to at least establish it wasn't us interfering with ourselves, as sometimes is the case. But as I say, I have one of these, which I'm going to try. I don't expect it to be as good as the larger loops that we use, but you never know. It has a unique feature I hadn't seen before, where it has a switch, which changes it from a HF loop to a VHF dipole. And I hadn't thought about that before, but yeah, it's like a loop is a dipole stretched out. So it's intended, they call it the FMDX position. So that'll be interesting to play with. I guess that's about it. Back to net.
Very good. Let's see. Oh, I missed Jim, K4BSE. Go ahead, Jim.
Good evening. Not a lot to report here. We have been dealing with storms too, yesterday and last night and early this morning. But looks like we got a couple of days of drying out ahead of us now.
Very good. Next on the list is Elmer. Go ahead, Elmer.
Unmute, that usually helps. Been doing noise reduction issues in my shack. I actually found an audio amplifier that caused RF, which was kind of interesting. It changed with the volume control. I also put up a copy of KC3EEY's VLF antenna today. So I'm deep learning the VLFF tools and getting that up and going. Back to net.
Very good. Next on the list is Jonathan, KC3EEY. Go ahead.
Hi, everybody. I've been kind of busy the past week with primarily non-VLF matters, unfortunately. But so I do apologize for those who have been trying to reach me, especially Elmer. I do apologize for not getting back to you. However, with that on that topic, Elmer, what you did was absolutely wonderful. Very nice build. Very nice build quality. I'm quite impressed. Very nice work. So I definitely appreciate that. And I will be responding to your email soon. And I also believe that if there's nothing else pressing to talk about, I think we should use the some of the general session time to talk about Elmer's efforts and how to move forward with it, because we one of the things that we need to as a group anyway, we need to figure out how to disseminate VLF data products. That's one of the big things, specifically how they're captured and visualized, and what data products that we get from these systems. And Bill obviously isn't here, but that's an important thing, because once these systems go out collecting data, that's going to be the next question is what do we do with the data, and what kind of data that we get, and how it could become useful. So that's definitely something that we need to address. And yeah, so yeah, if that's okay, I would like to use some of the a general session for the talking about Elmer's efforts. I have been working closely with KiCad and understanding nets and understanding routing, and just little details that you kind of need to understand, because I'm kind of beyond the point of doing like a basic layout, and now I'm into the more intermediate functions, intermediate to advanced functions. So it's still a learning process, and I'm learning as much as I can. I currently tried. So one of the things that I wanted to do to speed up the process, at least with the GPS interface, is to utilize a pre-existing design, which I used in the VLF system. It's called the PPS Piggy. It's an interface board for Trimble timing receivers. But I'm not necessarily interested in using the design specifically for those kinds of receivers, but for any kind of GPS timing receiver. I wanted to add compatibility to use either Trimble timing receivers or U-Blocks M8Ts with some form of a standard connection interface, which there really isn't for the U-Blocks anyway. So or at least a actual plug-in footprint. So I imported the PPS Piggy's design, which was done in Altium Designer, into KiCad, both the schematic and the board. The board was a bit challenging to import because KiCad gave you an option to go through each of the layers and match them with what would match them with, or each of the Altium layers to match them with the KiCad layers. And you can do this manually, or you could do this in an automated fashion where KiCad guesses. And so I picked the automated fashion, and it seemed to guess okay, but I still have to go through it. Obviously, this is quite a big effort, but we'll definitely get through it. That's all I have for now. Back to the net.
Okay. Next on the list is Phil, K9Q. Go ahead, Phil, and welcome back from your trip.
Yeah, I just got back literally minutes ago. We went out to visit my sister-in-law in Medford, Oregon. And well, while we were there, saw a couple of hams who just happened to been there. One of them, I believe, is on this call somewhere. Anyway, also on the way back, we stopped at the Hat Creek Radio Observatory. I've been there once before. I've been helping volunteer with the ATA folks. It's an interesting site, but it sure is out in the middle of nowhere. I guess you have to be out there in order to get any kind of radio quiet these days. And then we drove all the way through 2 days yesterday back to San Diego. So energy cost though was zero because we prepaid for electricity for our Teslas. Anyway, let's see. I think let's see. Nathaniel, you're on here. You asked me about support for the USRP, right?
Yeah, we've been having some discussions about that.
Okay, yeah, right. They have one up at Hat Creek. I don't think it's currently being used. It's one of the minis. Are they all basically the same in their interfaces?
I don't know the answer to that.
Short answer, no.
Yeah,
Oh,
I
they're
think
not.
not. I think not.
Yeah, I mean that thing is kind of pricey. I mean, I don't know. How do people feel about support for the USRP? I've never been interested because it is so pricey and a lot of lower cost.
Well, maybe we can spend some of the general session talking about the pros and cons of it.
Yeah,
I was having some discussion the other day with I think with Rob Robinette about whether or not to support it, but it's definitely worth more of a discussion.
Okay, all right, put that on there. Other than that, I don't really have anything else to mention.
Okay. Next on the list is Scott Newell in 5TNL. Go ahead, Scott.
Hey, everybody. It's been about a year since I started sitting in on these calls. So I'd like to thank HamSCI, TAPR, and especially all the attendees. I'm especially grateful for the patience y'all have shown to my silly little questions and all the interesting discussion, the advice, and even the homework assignments. So that's it for me. Back to Ned.
Well, we appreciate the effort that you put in on your behalf. It's
Yes,
been
thank
very
you.
helpful. And next on the list is, oh, Scott, did you have something?
No, that was me. I was just
Oh.
gonna say he's done some great things.
Yes. Next on the list is Tom in 5EG.
Oh, okay. Good evening, Dave, and everyone in the group. This has been busy. Got to see Phil last week, which was real nice, and have dinner. And we stayed away from too much shop talk, so hopefully, hopefully Phil's wife enjoyed the break away from shop talk. In the process of moving, and have got internet at the new place. It'll be a few more weeks until the Ham Shack is back up and running again. So back to the group.
Okay. Next on the list is Rob Robinette. Go ahead, Rob.
Oh, hello, everyone. I think many of you who received my emails over the weekend from the work I've been doing using Scott's tone burst detection. And I think we have established that that the system, the 888 and the and the K9Q are quite are not. I don't think they're dropping samples. I think the whole thing is quite reliable, surprisingly reliable. And I think this is really encouraging news for deployments and radio science measurements from the data that we're acquiring. Um, the Scott was essential in this because he implemented a Python routine that shows the tone burst offsets, and I probably can bore you all. I won't go into details right now in my summary, but I did I generate, and here's a recent example which is actually uh, needs clearing up. But this is a chart that is taken from wave file recordings at wwv/0, the receive site that Dave Schwartz has set up for us. It's six kilometers from the WDBV transmit towers, and the red dots, those are actually dots, are the offset in milliseconds of the tone burst that WWV emits on every at the beginning of every minute, second zero. You except for a minute zero at once an hour, when it doesn't emit the tone burst. So those spikes that you see are due to the fact that there's no tone burst there, and so it introduces it. So in general, once our system, WD Grape, starts recording, except for that step that you see at the beginning, after a while, the offset, the stability of the system is excellent. I mean, it's at the limits of our ability to measure using tone bursts. So I think this is very encouraging, and I can go into more detail later. But this chart is very much the result of Scott's work to help me. And there's ways we can extend this if we want to go deeper into this. But my concern was that Bill Lyle had observed that there was variations, that the recordings, the 1 minute long recordings, were not all starting at the same time, and that the tone bursts were varying over periods of hours and days. And I think apart from that step, and I can go into it, that in general that is not the case, that this system K9Q is extremely stable. It's not dropping any data. And I think we have a good reason to go forward with the system with great confidence. So anyway, that's been the core of my work for, I don't know, with Scott's help for the last 6 weeks or so. Bill Lyle's observations stimulated all this work on my part and Scott's part. And I think we've established that Phil, you're doing a great job, just a great job, uh, and I'm really impressed with the quality of the of the whole system at this point. I think we know how to build really high quality science quality receive systems here. So I'll send that back to Net. We can talk about details later.
Thanks, Rob. You must be leading up to a request or something here.
No, I'm actually not. I don't think there's anything for you to do, Phil, for once. I don't think I think that this is it just seems to work. I mean, if you were if someplace we were dropping 1,000 samples over, over 24 hours, I probably wouldn't see that. But we would absolutely see, and I think we're actually seeing an example here at the beginning of if there's if you shift and grab a block, an FFT block, I think it does shift the offset. But this graph that I'm sharing with you is for an old i5 8500T out there at WWV, and it's really CPU challenged. I mean, this has only 6 non-hyper-threaded cores, and it's running at 129 megasamples. So this CPU is being pounded by 250 megabytes per second of sample data, and yet it appears to me that there's never a sample lost. I sent out in my emails a chart over the weekend that showed absolute stability at 49 milliseconds. But only today did I realize that I had the system running at 64 megasamples. And Glenn Elmore in particular has emphasized to me that really it's pretty important to be running at the 120 megasample rate, that the RX888 is so RF leaky in and out that that it's you really if you run it at 64 megasamples, there's all kinds of external sources that can leak in and get aliased. That leaking and alias is reduced considerably if you run at the 129 megasamples. So I don't think that I'm building I have purchased a new B-Link that I'm going to ship off to Dave Schwartz that has a much more CPU power. And hopefully that will verify that even at 129 megasamples, that with the B-Links that we're specifying for the DAISY 2 deployment, that we will get absolute stability. And this is temporal accuracy. We've had, with GPS disciplining, we've had, frequency accuracy, limited by the GPS DO. We've had that for forever, since we figured out how to use the external clock on the 888. But this is the first time that we can establish that we also have temporal accuracy. Now there is an offset, of course, and this offset is a kind of a semi-random number. But once the first sample is taken, ignoring this step down, once the first wave file is recorded, all of the subsequent wave files have the same, are temporally accurate. And that means that the last sample of a minute 0 wave file, that last sample, the next sample goes into the first sample of minute 1. And I think that this chart demonstrates that to be the case. I invite, and I'm encouraging people to comment and correct me if I misunderstand the significance of these results. But I'm pretty confident that this is we've established that the system works well. The blue dot lines are at the bottom are when the wave files are created. How because the system clock on Linux varies. There's buffering, IP stack buffering. There's Linux scheduling delay. So these create times vary. They doesn't create the wave file right at millisecond 0 by any means, but but the fact that there's no correlation between the create times and the offset in that wave file of where the tone shows up demonstrates to me that this system is not dropping any samples. Certainly not dropping any FFT, 20 millisecond FFT buffers.
I want to jump in. This is Elmer. Between Phil, Scott, and Rob, this because I've been following this work from the very Rob will know, the very beginning. This is outstanding.
I
agree.
It's amazing we've been able to do it. Thank you, Phil, for the software environment. Thank you, Clint, who I guess isn't with us, for introducing me both to the 888 and to Phil, and to Franco, who I guess isn't with us. I mean, there's a whole bunch of people who've contributed to this project, and I look forward to having a better receive device than the 888. But what we have right now, I think, is highly deployable, and will give us recordings and results that I think will be meet and exceed the requirements of the radio science community.
Except possibly for reliability, and that's what Nathaniel was telling me about. He's concerned about the reliability of the hardware sending to places like Antarctica. And
that's a reasonable. I absolutely, I mean, I have now experience with maybe 50 ARC 888s, and for some people like Michael, who can't join us tonight, he's had a 50% failure rate, and but my experience in deploying systems. Hey, Elmer was a customer, and he knows that I'm we installed 100 systems at HBO for him, and he knows that I recognize the importance of reliability and the ability to fail over, that there be redundancy in the systems, and my belief is that at this stage we have so much invested in understanding the 888 and how to make it work and how to deploy it, that in my experience is once you get it installed and running, okay, with all the the protections for the external clock circuitry and the procedures to plug it in and all the components in the right order, they run. I mean, I've had I don't know, 4 or 5 888s. The first ones blew up on me out at KFS, and through that process, we learned how to protect the 888 in our configuration, external clock configuration, and protect it thermally. We protected the external clock input with the appropriate isolation and padding, and I think when you do that, I think it gets reasonably reliable, and for the equipment is so inexpensive that I think one-to-one redundancy, sending a pair of these things to an installation site, critical, one where it's difficult to access, is more likely to be a path to success than to try to bring in new components that we haven't worked with. And my understanding in terms of the what's that other receiver, Edis receiver, is I recall that Gamal has one, but it has only a gigabit Ethernet output. There's no way to get the raw sample stream out of it. So you're limited to the 900 megabits you can get out of effective payload you can get out of a gigabit Ethernet, and that's less than even a 64 megasample data rate. So I think the Edis, going to the Edis, you should look at the specifications of it very carefully before you start that project, because I don't think it's really suitable. I'm not aware of any alternative to the 888. Nobody else is, well, maybe, no, not even the red Pitayas. they they too have this choke point on the gigabit Ethernet. So you can of course do some processing, move K9Q into the Edis or into a Red Pitaya. To me, that's a major project. I think that it's more productive for us as a group to get our own 888 design and something anyway, that's my perspective on it.
Okay, one question I have is that when I look at the Edis boxes, they seem to be intended for VHF and up. HF is a little neglected by the commercial world because there doesn't seem to be really much interest in it. So that's why I'm wondering about support for the USRP, because the ones I've seen are mostly for VHF and up. And I just don't know how well they work, if at all, at HF. I mean, I'm certainly willing to do it, but that seems to be where all the commercial action is. I looked at the Mini, which I
Yeah,
happen to have at Creek,
I
and it's
I
got
think
this.
as I was thinking about it, I was just talking with Rob a little earlier this week because after I sent you that email, Phil, I did have a conversation with Rob earlier this week where he made a lot of the points that he just said now, and I think I'm tending to agree with his perspective right now. So my experience with the poor reliability of the RX 888 is based on I've had two of them that seem to have burned out on me, but I also have them connected to a computer that is a bit older, and I actually have some reason that I'm not entirely I don't entirely believe that that computer is entirely reliable either. So I think based on Rob's experience of having so many systems work well for him, I'm going to be replacing this whole computer when he comes out in a few weeks. We're going to be putting in 3 new B-Links, 3 888s over at my house, and we're going to try that out. I think the advantage and the Edis USRP is the ones I know that work with HF are the N200 and the N210, which I think now are like maybe 15 years old. And I think they are very expensive. They do have the gigabit Ethernet choke point. I think you're right that they don't have, we're not seeing a lot of HF development on the newer USRPs. So, yeah, I think Rob might be right that it makes more sense for us to spend more of our time trying to come up with our own 888.
Okay.
Yeah, if I could chime in, we've had a lot of experience with the USRPs. The N200, N210 type have had a lot of use in research applications. They do have a baseband input option, which is why we use them for HF. Generally, the other USRPs that are around seem to be, my guess is they're actually based on an analog devices chip that is 70 megahertz and above.
Yeah.
Mm-hmm.
And there are a lot of different versions of that, but that's not of any use to us.
Mm-hmm.
But the reason that we are talking about the N200 type is we have been using those for 15 years or whatever it is.
And that's probably the best
We've been
argument.
using them at Dartmouth. MIT Haystack has used a lot of them. UHA's used them a lot. UHA Viernan.
Mm-hmm.
So there are a number of them around. It's something that we trust as a research instrument, but they are very pricey. 2,500 is the basic price for them.
Yeah, it seems to be based on the analog devices 9364.
Right, that's the newer
right?
ones that's what everybody's seeing as USRPs, the Mini and whatnot.
The
Seem to
chip
be
is not
based
that
on that,
new.
but
I mean,
that's
that
not
chip,
what we're talking about.
yeah, okay. And that even
But
this chip is not all that new.
I guess
Yeah, because what the ones
best
we're
argument
talking about
for
actually have I think they have a zinc FPGA in them, and a normal baseband A to D like we're using in RX 888. The one advantage of it too is it's 2-channel, not one, and it
Mhm.
can also do receive and transmit at the same time.
Yeah,
And
this
So
bigger one is yeah, is a single channel, but transmit and receive full duplex, but transmit doesn't seem very useful to what we're doing.
not for us. I'm just
No,
saying that like I think
the end
the Red
settings are great.
Pitaya is kind of aimed at replacing what people have been using the USRP N200s for.
Yeah.
I think maybe, the best argument for supporting them is that, at least in the research community, there's quite a few of them around. So they're maybe not well known in the ham radio community, but a lot myself, I've got like 2 sitting in this room with me. They have a bunch at Dartmouth. A lot of my colleagues have a bunch sitting on their benches. They accept these daughter boards where you can put in either baseband A to D's dual channel. You can do one transmit, one receive. You can have daughter boards that work at higher frequencies, and then you can get a GPS module for it that will do that will both do pulse per second and GPS
Yeah, it has a
DO.
built-in GPS DO
So
that includes pulse per second.
Yeah, so it does have certain features, and they're built very sturdy. So, like I know there's already one down in Antarctica. So
I think we have 2 at South Pole. And we
yeah,
just had 2 installed of Steve Kepler's at Tulik in
yeah,
Alaska.
I think there's still one. I think Ethan Miller still has one sitting out at Jenny Jump right now. So
Probably.
yeah, so there's a I think that those are the reasons to support it. But in terms of my project, for Antarctica, if I were to, you know, if I were to put one down there, I wouldn't do it for at least another year, which by then, hopefully we have things working, but with the ARC 888.
Now here's a question. What's the difference to us, Nathaniel, between the USRP N200 and the Red Pitaya? Would Red Pitaya fit in with what we're thinking of doing? The only
Well,
the limitation being the Ethernet bottleneck.
Well, I think the really attractive thing about the Edis USRP is that it does have the built-in pulse per second and
Right.
the GPS DO. So if you have the pulse per second now,
that's true. Yeah. I guess the newer Red Pitayas have some external
but then
frequency capability, but
what about they may have external clocking, but like frequency stability, but to do the pulse per second.
That is a good point.
So with the Edis, you have the potential to actually do time stamping on the samples, right?
Correct.
So that's something that
we should figure that one out.
That the ARC 888 doesn't have. There's no way to.
As a rocket scientist, my comment is it's not rocket science.
So the biggest downfalls of the Edis USRP are that it's expensive and it is somewhat bandwidth limited compared to the RX 888, and it's not it's getting old, but it does have the GPS DO that you have the potential to do time-stamped samples. It's a very robust piece of hardware, and there's a lot of researchers that already have them sitting in their labs. So
yeah, it's unfortunate there is not a replacement for that. But I guess shall we say the hobbyist versions, they haven't focused on the frequency stability and most importantly the time stamping ability. I don't know how much is available on the USRP to figure out what all is happening in there. I know some schematics are available, but I don't know if the main board is.
Well, there's a block diagram, and you have the data sheet for the transceiver chip that's in there.
Yeah, I'm trying to think what it would take for us to develop the time stamping
I still think that,
capability that the USRP does.
I still think the best all around solution to the time stamping problem is the one that Clint suggested some.
I don't think a tone burst in the into the A to D is going to have the accuracy.
Why not? Well,
because
not a
it's
tone
very
burst,
band limited.
not a tone. Well, but
If you
no,
use the one
it's
pulse
as
per
wide,
second,
it's as wide as your input. It's going to be band limited by whatever channel you're listening to it through, but then so are all your observation channels too.
yeah, but any kind of tone pulse you put in there is going to have limited bandwidth. Whereas if you use the pulse per second directly, you can have it to nanosecond accuracy.
I've heard, are there other places or other people that are using that tone injection solution? I think Jonathan Rizzo, you're a fan of
Yeah,
that
but that's
idea,
at
right?
VLF where you don't need the same level.
Look, I mean, there's going to be, if you're trying to use this to timestamp the output of a filtered channel, well, the filter is going to add some delay, so you're still going to be off.
But it's a fixed and known delay.
Well, you got to figure out what that is.
Of course you do.
And
but you know that.
But any of these schemes, you got to figure out what that is.
If you do the tone injection, I mean, isn't that also a way of measuring the time delay of the system?
Sure.
Well, it nulls it out. It has an equal delay, so
yeah,
you don't even have to know what it is.
So anyway, what I like about it is it's simple. It can be produced as a separate little box you can put in front of any of these of SDR front ends. I like it, really.
Right. Well, it's a question of how accurate do you want it, but if we're going to do
accurate enough.
Yeah. I think
no,
so.
I
think we should table this discussion for now. I know that Jonathan really wanted to talk about what Elmer was doing, and since Elmer just got Jonathan's VLF system up, I think we should give a little time to that, and then I think we should come back to this discussion of where to go with the future with the new RX triplet design in the future. What do you think?
That's okay.
Yeah, Jonathan.
Thank you, Nathaniel. Yeah. So anyway, Elmer. Again, I wanted to apologize that I wasn't able to respond to that to your email. But I actually didn't get a chance to review it yet. But I was wondering, what did you end up doing for the antenna portion or antenna element portion of this?
So I went to Lowe's today in the pouring rain, and I picked up a 2-inch pipe, PVC, and I utilized the bottom part of that with a some plastic so I could mount it. And I can send you pictures later once the sun comes back up. And then the rest of the pipe that wasn't the receiver module, the amplifier itself, from there up was a wire that went all the way to the cap of the pipe. So that was the vertical part. And then I put a ground rod into Long Island sand. So every time I hit it, it went about a foot into the ground. There's not much ground here. I may add another rod to that rod and another rod to that rod to see if I can get down to aquifer or something like that. So that's the outdoor part.
Oh, perfect. Okay. And I believe in your email you asked me what the reason was for using foam and copper tape. Was that correct?
Yeah, I looked at the picture again. It looks like you were just doing an RFI protection, and the foam was just protecting the amplifier assembly while you put the tape around it. Is that correct?
No. Actually, the foam serves as, so one thing that you'll notice about this preamp and antenna is that it is extremely microphonic.
Listen, I could hear myself in the room.
Yeah. And so the person who came up with this original idea, Paul Nicholson, the author of VLF Arts Tools, he's been doing this. He's been into VLF since 2008, and he's experimented with antenna designs over the years, and he's found some recipes that actually work well. Some are kind of impractical, but they work quite well. The most his best antenna. This was his best antenna, but it's kind of hard to keep this kind of hard to keep this running. Is that he uses sand, wet sand in a pipe, and he found that it is the most quietest in terms of microphonics. The problem is that the sand eventually dries up. So kind of as a trade-off, he went with a foam insert, a plastic or a foam insert, which looked like to me like something similar to the foam used to insulate your water pipes.
Right.
Because actually, yeah. And so what he did was, instead of the wire, which I believe the reason why that he didn't want to use a wire was because it would be that there would be some form of resonance in that wire. He decided to use copper tape. And from what he has said, the copper tape on the outside of the foam pressed against the inside of the pipe, because there's some, like, there's some compression there. That was the quietest in terms of wind, because he would have a lot of problems with wind vibration.
Understood.
Yeah, and that was the reason why that he went with that design, was because throughout the years and in all of the different things that he tried, that seemed to work the best. And
so how long can let's call it the pole that heads above the earth, what would be the best length?
Well, so obviously the longer the antenna, the more more voltage that you're going to be sensing. So that kind of depends on the gain of the preamp. Now this is kind of a delicate balance here, because so what you want is you want the your input signals never to go beyond the scale of your preamp, because if it does, then it could generate a lot of nasty harmonics. And but the challenge is that you want enough gain where the loudest spherics won't overdrive your preamp, and but you also don't want your signals too quiet. So what he did was, because I asked him about this, and I said, well, I was going to use a antenna length that's about 6 feet, and he he gave me some capacitor values or a RC value, which would change the gain of the front end. And I'm assuming that you use you changed or you didn't change any component that was in the schematic. You
No,
pretty
no,
much.
it is built as.
Oh, okay. Here, let me bring up my schematic, because what I did was,
I mean, my goal is to match edit whatever you're doing. So I have a replica, even though I'm in a really crappy site due to local interference, but I'm trying to always build something that's already been pre-built so I can analyze any modifications against the standard.
right, right. Yeah, let me bring up the uh, schematic that I have. But anyway, there's a capacitor and a resistor that you just have to change to give a gain around 15 or 20. And that should be.
I have the schematic in front of me. Do you, what are you talking about C2 or C1?
I no, it's a different one. The schematic that I gave you doesn't have those
Okay.
Those modifications, because I asked Paul later on, but there was the schematic that I drew up in KiCad has that text in there.
Well, if you could send me that, I have KiCad capabilities.
Yeah, yeah. Okay, okay. So
the other thing I want to throw out real quick is the power supplies that are being utilized costs an awful lot of noise. And in my shack work, it showed up on my HF system. Now, I just put it outside and I had to run off to go see the wife. Too much information. And what I haven't validated is if this antenna system is near an HF system, if that power supply in the shack and outside are going to induce something into the HF system that's nearby.
correct. So you're using the IP2415?
Whatever that was in that list. Hold on, let me pull it back up again. Yes.
Okay.
One inside, one outside. And I tried putting inductors and capacitors on it. Noise level is still the same.
See, I didn't realize that they caused that much HF noise.
They are. I'm not going to say horrific because I still need to. Amazon's to deliver my copper tape tomorrow so I can wrap them. And I put the indoor system inside a metal case. But the concern is if anybody's trying to set up a very quiet HF system, that I keep doing the whack-a-mole. This will introduce possibly noise if it's nearby. Possibly.
Okay. I wonder if there would be a way that we could probably wrap wrap this unit in, wrap the preamp in copper tape, and then connect that to the
No, that's not the issue. The issue would be is, am I going to be radiating power supply noise, even down the Cat5 cable, if it's near something else? And again, I don't know. I just started this test, and I don't want to eat up this whole, meeting here for this, but the fact that I found, power supplies, audio amplifiers, all kinds of things in my shack that generate enough noise that I can observe it. And what I'm trying to do is make sure that we don't have another whack-a-mole. And again, placement of the antenna is crucial, because
yeah.
coupling could be mitigated by just positioning it further away, and maybe not
Right.
that far away. But I wouldn't want to co-locate it with the SAS or a DX or anything like that.
Okay.
Possibly. This is just conversation. I need to validate that there is actually radiated noise coming from the system, and I'm still waiting from Amazon to get my tape to finish. The last part was wrap the tape around the amplifier and its power supply. The indoor unit was put in the case this afternoon, but I don't see how it's going to decouple it from coming down to Cat5 and possibly radiating there. And again, Cat5 is great, but not all manufacturers are equal.
Right. And yeah, these DC to DC converters, they run at about 90 kilohertz. But I didn't realize that they generated so much noise. Because from what I was testing, it actually it wasn't too bad. It was a little noisy, but it wasn't too bad. They tend to get noisier when they get really noisy when you can't supply a voltage to them to keep them regulating. Then they get really, really, really noisy. But as long as you can, but if you can do that, usually they're not too bad. But I honestly didn't know. Did you notice any characteristics about this noise?
I just could see the pulses across HF. I didn't analyze it that close because it was just a bench test.
Yeah.
I'm now, like I said, deploying, and that deployment started today. I still want to reserve comment because I haven't wrapped the outdoor unit, and the indoor unit, like I said, I added additional capacitance around all of the ins and outs. I even tried putting inductors on the system just to see what it'd be like. And again, it may be that it's so low now that I can't measure it, but I just did observe it when I first turned it on in the shack, and the antenna was 35 feet away. So it's just one of those where I'm just raising a flag that I want to monitor that really closely, because I was searching for other supply sources, but they all seem to be variations of the same. If we go that path, I was going to put 9-volt batteries on it just to see how it would look with no power supplies and just have a 9-volt, two 9-volt batteries outside.
Well, see, you're right. There's so there's like there are quite a lot of different DC to DC converters out there, isolated. But yeah, they are kind of different variations on the same thing. Now in the early days, in Paul's experiments and others as well, they used batteries actually. they used what people would do is they would use a sealed lead acid battery, like a 12-volt battery, and uh, and they would replace it like every month. They would go out to the antenna. One would be trickle charging inside, and they would actually replace it every month. And that's been pretty successful. But for this, the reason why that I thought that the DC to DC converters, isolated DC to DC converters, would be useful is because people don't have to go out and replace the batteries. But I believe that you probably wouldn't see much, if anything, in terms of any sort of noise spurs, because there's not really much else generating noise other than the DC to DC converter. So I'm glad that you brought this up. And using a battery would be a pretty good test.
Well, what I haven't measured the current, and I'm just proposing possibly that if I were to place, not a good spot for me, but if I were to place solar out there, 2 cells, one positive, one negative, charging some kind of battery, how much power I would actually have to generate to keep it going in a sustained, cloudy New York day. If that would be far less noisy than trying to, send out a switch power supply.
Yeah, that's also another good idea. I mean, Elmer, these are problems that many people have encountered. This is the issues of powering VLF receivers, either with solar or batteries, or it's a pretty good engineering challenge, and I'm kind of glad that we're going over this, because this is the kind of engineering challenge that is definitely worthy of an investigation. But
Well, I'm going to go down the path of looking at, can I do a single-ended power supply, split rail it somehow, and not have a plus minus, but just run a single source out there, and then deal with a linear supply inside to drive out there and overcome the resistance with just enough voltage.
yeah, that's a good idea. But anyway, before I forget, I wanted to mention that what I did was, so I changed R6 to 6.8K.
I can't see that. Yeah? Nope. Okay, is this the same schematic I have that you're talking to, or a different schematic?
No, this was the one that I drew up when I was at the conference.
Oh, okay.
But this was a note that I had from Paul. So he wanted to, so for since, because he was using like a four foot antenna, so his gain was higher. But for me, since I was using a 6 foot, he was saying to lower the gain to about 15. So he recommended R6 be 6.8K and C3 be 680 puff.
Okay.
And that's currently what I'm using now on the VLF receiver.
And that's on the U1.
Yeah.
Okay, I got it. All right, I understand. I'll make that mod.
And for the antenna, I don't know what kind of well, so for the antenna, you could probably stick with the wire for now and see how that'll work.
Well, no, I'll put the foam in and wrap it once I have the tape. Right now I have the wire. You'd have to look how I did it, but it is suspended dead center in the pipe itself. Doesn't mean that it's going to resonate, but I
Yeah.
have because I have upwards of 60 to 40 mile an hour winds here. Not necessarily where it's pointed right now, but I put 3 guy lines to the antenna tube, 3/4 of the way up, but the wire itself is suspended dead center in the tube itself.
Okay.
That was today's design.
Yeah, I would imagine that would probably vibrate quite a bit.
Oh, it'll sing.
But yeah, but but just make sure that when you do wrap that when you do cover the preamp in copper tape, that the antenna elements and that copper tape obviously doesn't short.
Sure.
Because
Do
obviously
you take the tape that's around the antenna preamp back to the ground, or do you leave the shield just as a wrap around the amplifier?
well, so that would be something to kind of experiment with. I don't really know the answer. Mine isn't shielded. So yeah, mine is not shielded. I was thinking about what I could use as a shield, and see, I think it probably would be best if you don't ground that to the ground of the preamp.
Okay, so it's just a Faraday cap around it.
Yeah.
I originally came up with this. I don't know if you could see it. And it was all bonded. And I tried this in the shack, and this actually, this took measurable signals down to nothing, but it was a copper container. But the tape will do the same once I wrap it.
Yeah. Yeah, that's actually really nice. But yeah, my guess is, and this is just a guess, that probably would be a bad idea if you grounded that our little shield, because I kind of have a feeling that would have an influence on the capacitance of the antenna. Because the challenge is that, let's say that we wanted to model this whole circuit, right? And if we did, then we would have to take into account that shield as well as part of the circuit. And I believe it would have a greater influence if any currents on that shield would be able to get to the ground circuit of the preamp. So yeah, if you do use a shield, my recommendation would be not to ground it.
I'll put a switch on it. We could play.
Yeah, that's
I mean,
a good
literally, I'll put a switch on it. We could turn it on and off.
Yeah. Yeah, because I mean, it might not have that much of an influence, or it might. I don't really know for sure, um, but yeah, I think this is all really good. Um, were you hearing? Um, did you actually listen to the output?
I did. I fired up the audio in LF Tools, VLF Tools, after the filter, and I
Mhm.
was, I wrote Clint because I know Clint had been doing work on VLF for a long time ago, and it was interesting that I was hearing, I don't want to call it Morse code, but tones that were some kind of sequence going up and down, and it was um, predictive. In other words, it kept repeating itself. Uh, and then I had to run away. So I only had like 10 minutes of listening,
Mhm.
but there was definitely something going on, and I could not determine what it was. I unfortunately didn't get the antenna up in time for the lightning storm that went through here just recent, and I don't see anything predicted for quite a while yet. So it'll be interesting to see what the snap, crackle, and pop sounds like. I do have, was it Toga? If I'm saying that
Mhm.
right, up and running with the prescribed filter enabled. Um, I'm not recording anything yet at this point because, like I said, I'm going as fast as I can.
Mhm.
What I want to do is start recording the audio and capturing um, sequences, just in case I do capture something, I go back and listen to it.
Well, and what you can do um, is and I can email you the link. So Paul set up some tutorial pages how to do a basic setup of VLFRX tools on a Raspberry Pi, but it can be done on anything. And one of the features that you you can do with VLFRX tools is you could actually stream it to an IceCast server and listen to it live on an IceCast server. Um, so you you could run it through your mains filter, um, and then you could run it directly to your IceCast filter for a live listening. But did you actually like connect it to some sort of audio amp
Yep,
and a speaker?
yep,
And
yeah. Stereo system, good enough from DC to daylight.
nice, okay. And did you actually hear spherics, like the little cracks and pops?
I not this go around. Earlier when I was experimenting
Yeah.
and I was just grabbing something out of the SAS, we had lightning storms and that group of storms that were down south that wiped out our poor buddies down south. I was listening to those going off, and you could, it was just awesome how that sounded. But looking today, just like I said a few hours ago, there
Mhm.
it was fairly quiet in my location right now. And again, I just plugged it in, so I have to validate that I didn't screw up anywhere.
Okay. All right. Yeah. Because so um, at at any location on Earth, you should always hear spherics. If you don't hear spherics of some sort, and they don't have to be local or fairly distant lightning storms. Um, it could be thousands of miles away from the nearest lightning, but you should
Right, but not
always.
having sat in front of a stereo, hearing those, you haven't. Is there a web site that I could go listen to what that should
Yeah,
normally sound like?
yeah,
Okay.
absolutely.
Uh,
Let me bring it up for you. I will put it in the link. Um, actually, I could. Here it is. I could give you. You can actually listen to on my VLF receiver. Here, let
is
me.
that the one where you post? I saw there was a posting, but I didn't listen to them. A whole series of audios?
I think so. Yeah.
Because
Um,
I was going to turn on my induction oven to see what it sounded like.
well, um, So listening to your local interference, like what you were describing earlier, like a sequence of tones, that sounds a lot like local interference, and there's
Oh,
a lot of that.
I have plenty of that.
Yeah, yeah, yeah. There's actually quite a bit of it. So and it comes in all flavors. So you'll definitely notice that when you do some more listening. But so this is what I posted in the chat is a link to um, the page that shows my um, our receiver, and it should come up to a page that says event gallery. And if you go to the play stream section, um, that will bring you to a page that will load up a player, and you you could actually hear what it should sound like.
Okay.
Now, this is after mains hum filtering.
Yes, I have that enabled.
Yeah.
That's the sample. That's the sample that's in the tools document, right?
Yes. Mhm.
Yeah. Okay, that's up and running.
Yep. Are you using threshold 5?
Huh. You think I remember this stuff?
Well, so
Filter is TH7.
oh, okay, okay. So the Paul kind of recommends about you know around 5.
Okay.
Um, the thing is that if you go too low, that then you get a lot of reverb. If you go too high, then it doesn't um, doesn't notch out the harmonics very well. So you kind of have to pick like a and Paul kind of recommends 5, but you could experiment with different values according to your location.
Okay. I just changed it.
Okay, and there's also so by default that TH5 it's set to go up to harmonics of about 6 kilohertz. By default, you could increase that if you want to. So if you have particularly strong mains interference, then you're going to get your harmonics above 6 kilohertz are going to be louder. So there's an option you could pick. I think it's UL upper limit. You could do 8 or 10 kilohertz um, if you want to. But those are all things that you can experiment with. But in most like what you would call radio quiet locations, like where Nathaniel is, a threshold of 5 is usually good enough.
My neighbor's New York. Remember?
Yeah, yeah. Yeah, so it kind of depends on your location. So you could kind of mess around with the values, and but the main thing is that you should hear spherics all the time.
Okay.
But you're definitely on the right track. You're definitely doing really well with this. And let me get you the link. I'm also going to put in the chat another link, and that's going to be and this is a really useful guide. So this is Paul's guide for setting up VLFRX tools on a Raspberry Pi. Um, but it really doesn't matter what it's set up on. But for the sound cards that he mentions in this guide, he mentions the audio injector sound cards, which are for the Raspberry Pi. But since you have the
404.
Behringer,
I have the 404.
yeah. Since you have the Behringer, it's obviously different, but it's you're pretty much dealing with the same thing. So yeah, let me paste this in the chat for you. And this is a fairly comprehensive guide, and it should give you it has a lot of great information. And it starts from the you know setting up the capturing system, setting up timing, hum filtering, listening to signals, monitoring, um, uh, sending data to a disk, um, event detection to detect blisters and dawn chorus, sudden ionospheric disturbances. It goes into like basically from start to finish, from to set up a system. And this is actually what I use to set up the system that I'm running right now.
Oh, cool.
But yeah, I think that should be it. Do you have any more questions?
No, you have. No, I have plenty of information here. I will inhale this, and hopefully Amazon delivers the tape. I will finish the antenna assembly like we just discussed. I'll float the shield around the amplifier, but I will place a switch on it so it would be a matter of a simple run out and flick it to see what it does, if anything different.
Okay.
And the well, too dark. I have the you won't be able to see it, but I have the board here inside shack board in a case. So that's all isolated and floating, but inside of shields. I'm attempting to meet or exceed what you're describing so that I can mimic exactly what you're doing.
One thing that I wanted to mention, and I don't think that I'm assuming that you got all the information from Michael, but there was one thing that I wanted to mention with the shack board. So the DC to DC converter that you use on the shack board, how I have it connected is I have a 10 megohm resistor from the common pin to ground. Is that what you have too?
I will be installing that tomorrow. My resistors came in, so I can actually attach that. That's just a static drain, right?
Yeah.
I'm not worried about that. Everything's laying on the ground at this moment, so I'm not worried about Mother Nature touching me yet. But I will be installing that resistor.
Yeah, it also kind of keeps the output kind of at check, and I'm kind of wondering if it would do anything to the noise.
I'll know tomorrow.
Okay, perfect. Yeah, I think you're on the right track. Yeah, just kind of take your time with it. Have fun with it. I definitely appreciate that you're doing this.
What I want to do is give you access to the system too once I get up and running. I've been working with Robinette on WireGuard and things like that, so maybe we can give you access to it so you can jump on board and do experiments as well without me being here.
Oh, perfect. Okay. Yeah. Nathaniel has an auto SSH set up where I could access the system. Unfortunately, his provider uses CGNAT, so he doesn't have an external IP, but his the auto SSH works quite well.
I'm creative.
Yes, yes.
Determined.
Hmm. But Nathaniel, do you would think that this discussion went well? Because I think that Elmer is definitely on the right track here. He's doing really good with this, and I'm kind of excited to see what he comes up with, because this is kind of I didn't have time to do more experimentation and refining of the design, and I think this is good that he's doing this.
I absolutely agree. I think this was a good discussion, and I think continuing to go along this path is a good idea. And Elmer's going to be here the week of April 21st through 25th, along with Rob Robinette, as you know, Jonathan. So hopefully you can join us as much as possible.
Excellent.
And I'm going to bring my antenna out there, by the way, hopefully.
Great.
Oh, awesome. Okay.
Yeah. I want to put it side by side to see how we perform.
Oh, cool. Okay.
Just saying.
Yeah. No, I would say that yours will probably perform better than mine. But yeah, this is actually really good. And once we get like we could get like a system running with with VLF RX tools, I can give you I could also give you my startup script.
Oh,
However,
that'd be awesome.
but on that second link that I posted, it tells you how to create that very same startup script.
Okay. Yeah, I know in the tools itself, it tells you how to launch the card, do the wait, yada yada yada. It's going to be a mini whisper demon.
Yes.
Hey, Rob, another mini whisper demon.
Yes.
Rob's smiling.
So it's yeah, yeah, on the in one of the sections there's a it tells you kind of how to write the script, and basically what he has going is that VT card launches, and then VT time, and then VT filter. Those are the main three components, where it's capturing the signal, refining the timestamps, and doing fine and coarse calibration, and then filtering the all the mains and the harmonics. And then from there, the signal is kind of piped to the event detector, the SID detector, and he has it piped to IceCast, and he has it has the signal written to a disk. Like if you follow that guide, you could pretty much have a full working system.
So, understood. I guess just like all the other systems that are capturing, where's the data to be forwarded once we do capture it? I look at Nathaniel. Where is? Yeah, somewhere.
Where does all of our data go?
Yeah. I'm just curious if there's a format for communication.
So ultimately, all of the data is going to, at least the raw data, one place it's going to go is Bill Engelke's University of Alabama server, right alongside all the grape data and the magnetometer data and everything else. And then Jonathan may also wish to send his data up to Paul Nicholson for the VLF in the format that he's already been sending it.
Okay, so there is a format that I could start looking at?
Uh-huh.
Okay.
Yes. Yes.
Excellent.
And again, this information is in that tutorial link that I sent you. So
Okay.
So the data is it's archived to disk in VLF-RX tools format, which is the which is basically it's the raw PCM data with time stamping. And then there's also the captured events. So like any whistles and dawn chorus,
Okay.
it'll kind of snip off a 6-second chunk from the stream that the event occurred, and then it would put that in the events folder. So what it'll give you a spectrogram thumbnail snapshot. It'll also give you some text information based on the detection, and it'll give you a VT file, which then you could convert to WAV. And actually listen to it.
So,
and then thirdly,
I'm just curious, are you going to be available during the week that I'm at Scranton to possibly sit down for a couple of minutes and just go fast forward with all this?
Yeah, absolutely. I'm going to be available the days that you're here.
Okay, cool. Then I will be not sleeping, but working on this too.
Yeah, I'm going to be. I'm already putting in the vacation time at work. But yeah, I could actually go through with you and show you the system and how it works. The script and the streaming. But I also wanted to mention, so the data that you capture, so there's another option to send the data over the internet as a stream, as a live stream, a Vorbis compressed stream, and that is sent to Paul Nicholson's server, which listens to the stream, and then it also runs. So it runs the event detector, and it runs other applications and analysis to generate the information that you see on that website. That's the first link that I showed you. But
okay,
I apologize, Elmer. I'm kind of jumping all.
That's how we learn.
Yeah, it's this system is this software tool set is so versatile, and it has so many different options that it can be really confusing at first. That's why this guide, the second link, should give you a much better idea on how the signal actually flows, and that would probably be the easiest way to understand everything.
Cool. Well, I am just so appreciative of all the effort and the conversation at HamSCI about what you've been doing. This is just overwhelming. All the DC to daylight. That's how I'm looking at it.
Yeah, I'm definitely very appreciative of your interest and your efforts, because this is wonderful, and I'm really glad that you're doing this. This is really interesting stuff. And then once you get into it, once you if you have an environment good enough, and hopefully that you do, and you listen to your first whistles, that's when it's going to get really cool. So I'm you know, kind of looking forward to that.
So here's the other thing. Instead of
Yeah.
trying to send the signal over the Cat5, as I'm going to call it baseband,
Mm-hmm.
I started this project and then I dropped it because I just didn't have enough time. But then I met you and I got so inspired. I have this converter, and it's
Mm-hmm.
cheaper than all get out. But the idea would be to take the antenna output into this and send it at 4 megahertz up the line, avoiding all of the problems of VLF over Cat5. And then Scott and Phil don't know about this conversation yet, but I'm going to announce it. I wanted to be able to take this output into the RX-888 and demodulate it there.
That's a good experiment. That's from what I because other people have also done similar stuff, and um but I don't know if they went to the um if they actually did something similar to what you were doing and then actually monitoring the or capturing the signal. So that would be another very interesting experiment. Although we would have to figure out a way, like, so we'd also we would need to figure out timing, how to filter out the mains hum, and do the various analysis.
Elmer, what was that converter you have?
It's oh, let me see if I can remember the call sign on it. I bought these years ago. It was, hold on, I'm getting
Is
the eyes
this
to
an up
focus.
converter you're talking about?
Yeah, it's a WB9KZY LF converter, and I bought a couple of
Uh-huh.
these. I lost one, but I stuck one away, and when I started this project, I pulled it out. So a couple of days ago, I assembled it, and I put the 4 megahertz crystal in it. And the idea would be not transmit, as I call it, wrinkle DC up to Cat5, but this signal, because I know that
Right.
Cat5 will carry it really easy. And then if I was DC out at the antenna, be it the solar panels or whatever, all I would be bringing back from the antenna would be 4 megahertz with the signal carried on it, which then,
Yeah.
because
What's
RX-88 came
the
along.
what's the chip on that? Is that a 602 or something like that?
Oh shoot, it's a cheapie. Hold on, I'm gonna wipe out the lighting. I used to know these parts. SA 602, yeah, 602AN.
Yeah, I thought so.
It's a regular mixer.
Yeah,
It's a
you'd have
cheapie.
to have all all the proper preamp beforehand, but it'd be interesting to see if you could get that to transmit the signal up the line.
Again, it was just when I start a project, I go in like 20,000 directions.
But that
and
is actually something that has been done. That's
okay.
Up converted. There's some commercial products.
Hey, I'm always late to
available,
I'm late to the game every time of my life.
Right.
I'm the end of the
I think the RTL SDR product line, there may be, Noah or somebody may have a similar product. But yes, up converting VLF higher so that you can digitize it and demodulate it better is a thing that is done. So, worth a try.
Yeah, well, it's just available for playing around. And again, every time I build something, I build 3 of them, as Rob will know. I have numerous antennas on the roof, and I'll probably build another VLF system and install this to see how it compares side by side.
Yeah, that this is actually really good. These are all really interesting avenues to take. Obviously, this is something that, you know, you kind of have to do the experimentation and you know, messing around to you know, kind of see what works the best, what doesn't. You know, this is kind of a whole new territory for everybody. So, but yeah, people have used people use those up converters quite a bit for SAQ on their ham rigs. Have their VLF antennas, and they use that to be able to listen to SAQ on their antennas or on their ham rigs. Um, that was actually one of the uses um, that people use those for. So and obviously for LF, if they have a rig that doesn't go that low, obviously you need an up converter. But yeah, that's another interesting avenue to try. And unfortunately, with VLF and with these natural radio signals that we're interested in, the whole baseband capture can be a fairly difficult thing to do because of all of the local interference, the difficulty in transport from, you know, from pre-up into the shack and all that stuff. There's quite a lot of problems with this. Um, but um, uh, with you know, but the reason why that Paul uses this software, or Paul wrote this software and he uses these sound cards, is because he's found that sound cards are often really good quality VLF SDRs. You could capture the data quite easily and do signal analysis, which is why that he's a big fan of using sound cards. But yeah, there are other ways to do it, and this might provide some interesting results. There's also Elmer, one fellow, what he did, he created a fiber optic link using that PMMA fiber, plastic fiber. The link was amplitude amplitude. Uh, um, it was an AM link, and one of the biggest problems that he had was getting it linear. So he was able to force it to operate in its linear region and still have quite a bit of bandwidth. And that's Mike Smith, and his VLF receiver is also um, on the first link. If you look at the other receivers, that's Forest, Virginia, and you'll notice on his receiver it's very, very quiet, and or in terms of noise, it's very, very quiet because he uses a battery, and he uses the fiber link, and it works quite well. And that was one of the avenues that I was actually going to take, was using a fiber link, similar to what he did. But that was what was the main challenge, is getting it to operate, getting the fiber diodes to operate in their linear regions, which he was able to do with careful setting of the gain and setting of the current. I could get you the link for that if you want. Would you like me to do that?
Sure. I'm game for anything that's possible. I was just trying to figure out then, because I haven't looked at it, where I would buy that fiber optic cable and then what it would take to terminate it. Because I used to have fiber in when I worked in my business, but it was much different fiber than a plastic that's used for like a TOS link for your audio and your stereo system.
Mm-hmm. Yeah, that's pretty much exactly what this fiber is. It's
If I can find it, that'd be an awesome side project to run with all the other million projects I got going.
DigiKey has it.
Okay.
The fiber transmitter and receiver was the ones that he used weren't made anymore, so I had to find them on the different websites. But this is the link to his website, and under the page content, there's a heading that says a better alternative, optical transfer. And if you click on that, it'll bring you to a paragraph which brings the link, which brings you to a link optical transmission system. And that page has a complete write-up of how he did the design of his VLF optical link. And it's actually something else. He you know, did a really good job of it. And on this website, you could view his VLF data, whistlers, SIDS, things like that. But that is also another good resource.
Yeah, the only thing, I'm not sure how far the plastic fiber would transmit. Is that what you're talking about, Elmer? What you have?
Well, no, I was thinking about the actual finishing of the end of the plastic because the photons have to couple, and if you don't have a nice cut at the end,
Yes, indeed. But I mean, Toslink's designed to go a few meters. It's not
right. It's
designed
back
to
of your
go
TV.
100 meters.
Exactly. Well, and there goes you have to pump up the current to get the light, then you don't have linear.
Well, Toslink, well, if you're going to do it linear, that may not work all that well. But, you know, if you use Toslink specifically, you digitize it and send it as as a SPDIF stream.
Yep.
That's actually an interesting idea.
Well,
So,
I'll go look at the site and see what's there. I mean, worst comes to lousy, I buy some cable and see what the loss is, or optics.
Right. Well,
yeah,
there's plenty of good cable around it. Really, you can send the same format down any fiber.
Sure.
So, the one that you're talking about, Jonathan, did you put a link in, or do you have a link for that?
Yeah, it's in the chat.
That's the last one you put in, the VLF current system.
Mm-hmm.
And that has fiber in it?
Yeah.
Okay, I'll take a look at it. Interesting. Well, I think it's time to QRT here. But interesting discussion.
Oh, just one more last thing that I wanted to mention. So the fiber that he uses is SH4001. And so with the link that he built, he says that he is able to get usable length up to 75 meters.
And it looks like he is doing it linear.
That's fairly good distance.
And yeah, his site was actually has been running for years, like over 10 years. He first introduced, or he first installed the fiber link, I think in 2013 or 2014. It was at least 2014. So it's been running quite well for years. And the actual link performance is actually really good. It was a really good.
Oh, I see how he's doing it. It's voltage to frequency modulator.
Yep.
I actually have those here. Built it for a different reason.
Well, no, his links are they're amplitude modulated.
No, they're not. He says it's FM. I think, or well, that's state of the art. Okay, maybe I have to keep. Okay. Huh. All right. I guess that's not right. Yeah, he's got a whole error analysis of the optical link.
Yeah, so this link.
Oh, okay.
It's amplitude modulated in the linear region.
Right. Oh, I see.
And it works quite well, but obviously the only drawback, of course, is that you have to go out every month and change the battery. But other than that,
well, that's why there's sun. You use the sun to take care of that.
Yeah, nowadays just put a solar panel on it.
Yeah, you don't really need anything that's switching. You just need some current limiting just so you charge the battery, just like the damn lights out in the street for the the pretty yards.
Yeah, in fact, yeah, interesting. You could get take apart one of the lawn lights.
I've got a box of them. My wife bought them, and I refuse to put them out.
yeah, that's an idea.
Okay. Yeah, that's very interesting.
Yeah.
And I'll just mount them on the antenna pole.
Well, you want to be careful with that because it could become part of your antenna circuit.
No, I said that. I said that in jest, but
right.
I just got to get it off the ground so that snow doesn't cover it up.
Right. Yep.
But the idea of using the sun to charge it, and then just force a signal into the shack, and then have something linear inside the shack because I don't care about weight and size. There'd be no more noise.
Yeah.
Yeah, having a solar panel powering the preamps, that will be useful for our HF stuff as well, potentially. Not so great in Antarctica during the winter, but for us.
Well, Rob and I were talking about doing that at somebody else's facility.
I think the Antarctic, that 1,600-foot run of RG-58 too bad there's no sun down there half the year, but
Yeah. Oh, by the way, it was more than 1,600 feet. I just
Oh,
looked at the map. It's 2,100 feet. So
geez.
that's what we need to compensate for.
DC won't even make it over that
I
length.
think-
That's ridiculous.
Well, I wasn't there when it was put in. That's how far out they put the antennas.
Well, I was talking to Rob about the coax that I recommend to put in, but that's another story.
Well, we have other coax that we'd love to put in, but it's a major task to trench and bury cables in Antarctica.
I understand.
We can do it. We may do that for like in 2 years when we can actually get down there, but for right now, we have to use existing infrastructure.
You're just gonna need a 10-watt transmitter to linearize the cable back to the shack.
Yeah, basically. Well, it does have potentially 30 dB droop. If you're trying to get 30 megahertz down, it has something on the order of 30 dB loss at that, unless at lower frequencies. We have it compensated, but it's we only are pushing 5 megahertz down it. A little easier task. Well, very good. $73 all.
Well, I'm gonna bail too since I'm on the east coast, probably more east than anybody else. Jonathan, I appreciate all the effort you've thrown at me. I will be engulfing and devouring and reading, and I'll send you any questions I've got.
Yeah, and as I said before, I do apologize for being late with your
Oh, hey, stop. No. This is a hobby to me. There is no deadline.
I kind of wish that I could make this my full-time job. I had the chance to do that a couple of years ago, but I decided to take a career that was, or at least I felt was more stable. So, but it turns out it never really panned out to be exactly what I wanted. So, but yeah, this is something that I kind of wish I could do every day. But yeah, it's a hobby to me too, but I kind of consider it a very serious hobby.
Well, I only get up at 5:30 in the morning to start my day, so okay.
Yep, yep, yeah. I get up about an hour earlier, so yeah, that's
Oh,
yeah. But
all right. I
yeah,
gotta go. I really gotta
yeah.
go.
So as I said, any questions? Feel free, and we will talk soon.
Thank you, sir.
All right.
Appreciate it.
Thank you, Elmer. Have a good night.
Good night, all. 73s.
73.
Okay. So I guess we're done. We didn't we lost everybody. Hey Scott, you there? I guess not.
Yes. Yeah.
Okay. I just
Had
wanted
my
to
headset off. Sorry.
I just wanted to thank you and kind of encourage you to take a break because I think we've gone far enough in our testing for me to feel like uh, you know, it's they're better places for us to invest time than in further validating the temporal accuracy. I I'm I did notice it looks like the that chart I showed earlier, um, where there was a step down, you know, to the tone burst time step down. That was that happened on at when I forgot the original charts, the ones I was showing over the weekend, sharing over the weekend, were I hadn't realized they were being made at 64 kilosamples, megasamples. So this morning I realized that, and I turned up the sample rate to 129, and it stresses that I5 8500. I think it's still working reliably, but I I have I'm going to let it run overnight and take a long term view of see if it so. But even if it isn't stable, that isn't the target platform, and I have a B-Link ready to
Yeah.
ship off. So that really that matches what we would be deploying um, at the Daisy 2 sites. So for all those reasons, I think I'm kind of stepping back. I'm working since I think that the client side is pretty well stable. I don't know if you saw, I checked in and merged, pulled in the 331 stuff into the main branch of the.
Yeah, there's a trick you can do on GitHub, and I get an email every time you do a commit.
Okay. Well, my
And
son was
it
here,
was
and
a
he's
massive email.
yeah, yeah. My son was here last night, and he's a GitHub jock at Apple. So I took the advantage, you know, that his visit as an opportunity to do that merge. I mean, he said, you know, you've gone so far out on this branch, you know, that he really says what the way most place system development is that they do a branch and that becomes the stable release. And then the main trunk is where the further work is done. And I've kind of done it backwards. I left the main trunk stable and did all the development work on the branch. So, but I don't think I'm going to be doing a whole lot of, you know, major changes to Whisper Demon. I think this 332 is pretty well you know, there will be, there always are little, you know, bugs and things to fix. But I don't, at the moment, I can't think of any major features missing from Whisper Demon in any of the applications I'm aware of. So I'm turning my attention to the server side because our server infrastructure is really fragile, and I want to um, I want to bring up. We have a couple of backup Whisper Daemon servers, and I want to get even a third upgrade all of them to new hardware, and and get that working. So I'm gonna be spending my time mostly on that and supporting and migrating everybody over to the main trunk. I'm sure there will be I you know the first two I did I ended up with incompatibilities. It turned out that Radio D previous versions were allowing duplicate multicast names, and so when I pulled in on the site that was running 323 and I upgraded it to 332, Radio D complained and wouldn't start. And that was a bug configuration lurking there.
You
And
know, I think I may be partially responsible for that.
yeah,
There was a bug that Tom McDermott tripped over on K9Q Web. He
yeah,
used the example configuration file and got some really strange errors. And I was
uh,
able to duplicate it and track it down to a duplicate multicast name. And so I sent a pull request saying, hey, you know, we can't have this. It's causing problems. And I didn't realize what it was. And
yeah.
so that error message you saw may have been from that pull request.
Okay. Well, I don't think you were responsible for this configuration error. This was at W4RVE up in San Juan Islands. Um, and but anyway, and I did an install on a Pi 4 with only Kiwis, and that upgrade went completely smoothly. So those were the kind of outliers, two outliers environments, but there'll be people with Mint OSs and things like that that probably will require some attention by Michael and me. But I've got to get ready for this trip to Nathaniel's in a couple of weeks, and work on the server stuff and other things. So I'm going to. I don't think you'll see a whole lot of, hopefully not a whole lot of changes in the background. And I'm not gonna work much on that graphing program either, because I'll do little tweaks on it to suppress. I don't recall, you did a WWV tone _4 version, which I haven't tried or incorporated. What did you do in that? What's the difference
Oh,
between
that's okay. The difference between 3 and 4 is that in 4, I stole your regular expression from the validate wave file script to pick out the date and time of the wave file. And if it's the top of the hour, it does 1500 hertz instead of 1000 hertz. So it's like 3 or 4 lines changed. It's really straightforward. And I did test it, and it does work. And the difference is incredible on of course, the top of the hour, it works now. It didn't before. So
yeah, well, and I was just suppressing top of the hour.
Well, switch forward. You won't need to.
I said, I can skip that one, and I just substitute the running average for the.
Sure.
But if it's that simple a change, I might as well. It's nice to, then I don't have all this special case. The other thing that I'm running into in my script is that fairly frequently, I'm getting create times that are in second 59. And even on the first wave file. And I'm wondring, I mean, these are,
That's weird.
5 or 10 milliseconds, from second 0. So they'll be 59.993, create times. And I'm wondering, how could you, I mean, I presume you're looking at the system time and waiting for the transition, and then executing a create. If you look at the create time logs on the you can log into WWV0, right?
Yes, sir.
Yeah. Well, if you look at the create time files over there, I think even the ones that, let's see if I can find. I'm trying to find my WWV window here. Oh, I don't have it anymore. Okay. Oh no, here I have it. Yeah, let's see. Let me share this with you, and let's see. Where is the? I've lost the Zoom window, and there's Zoom, and
I'm
here's
wondering
share.
if I create that file sooner and don't start writing to it until I see the first packet in second 0.
Yeah, I think you may be, and that's
Seeing session file in it. Let me see. Yeah, you may be right. No. F open.
Well, you see, here's the job I started, the log files. This is the first thing I started, and you see you see the birth time.
Trying to zoom here.
And you can see how that it started, and you see the tone burst was here. This isn't your problem, but you see it dropped after a few minutes from 71 to 58 milliseconds. And you can see here's I'm not properly detecting the top or suppressing the minute zero.
Okay, yeah.
But that's not that you can see that many of these, they're within a few tens of milliseconds. It's very close. Oh, look at the offset dropped 41 now. This I think is because the CPU is too challenged. I suspect that the Lin threads are just somehow eventually catching up, uh, and able to finish some 20 millisecond block early enough that they can catch up by one block time. I mean,
Then it might be interesting to switch over to that patched version of Radio D with the metadata.
yeah, well, it's as I say, this is an impaired system, so I'm not sure that I want to invest a lot of time. The only reason to do that would be to validate our code, that it's doing what we think, you know.
The other thing is I'm still not convinced that the system clock is very good on this system. If it's just running the system D time and date control and not running cronny or not running NTP, I don't know.
I don't, I mean, it's, if you look at system, time date control, right? Oops,
I don't remember the command line for it.
I'm the time, date, time, sync status. It's the offset is, yeah, you're right. It may be drifting around. This is more than offset that I've seen. Jitter. Ooh, lots of jitter. Yeah, I think you're right. I mean, I wouldn't invest too much time. If you're creating at a time you think is right, then I think that these numbers suggest that it could just be so much jitter in the system clock that it jumps back and forth.
Now, you said the very first wave file that PCM records is sometimes in second 59.
You're seeing it right there. Here's the right. This is the 10 WWV 10 megahertz log file, and I just
Right.
started. I just this. Well, good question. Did I? I don't know. Let's stop it and
Isn't there a Sentinel?
let's restart it and see what happens on these things because this is okay. So if I do a WDZ here to shut the whole
You
thing
say-
down.
If you say so, your bash aliases are a mystery to me. I'm
Yeah.
waiting for Michael to catch up.
Well, that's my. This
He's-
thing is this does all kinds of system.
I- Yes, I agree. It's great.
Yeah.
And it's terrific what Michael's doing to document it so the rest of us can
Yeah.
use it.
It's wonderful. It's wonderful. Anyway, I eventually one of the things I should get to is help him document all of this stuff. But anyway, we've stopped all of it, and I'm going to go to CDT, top of it, and I'm going to do a refined. Okay, here's all of the. I'm going to RM all of those. Okay. Oh no, yeah, that's right. Okay, there's others. So let's make sure we've gotten rid of them. They're gone. So let's do
Gotcha.
I'll start everything up.
Do you want me to switch out and put Cronny or NTP on this machine so that we can not worry
No,
about the system clock?
we'd have to do it on, I think we should, I've been trying to leave these systems alone. It's kind of rather than either that or because
Yeah.
either if you switch it out, then I'm gonna feel like I need to have Whisper Demon do it on, and I hate to intrude into systems. You know what I mean? I just
Absolutely. I feel uncomfortable about doing it without
yeah,
permission as well. But
yeah. You know, I've tried to not modify as few system files as possible. Let's see if let's look at the find and see if it hasn't yet. It won't create until it gets the first. You know, it has to get to the top of a minute. Let's see where it's at. Yeah, we'll get some all of the WAV files will be created soon.
then we have to wait another minute for them to be complete, right?
That's right. Then for
well, you could run stat. You could find an Xarg and stat them.
yeah, we could do that. Yeah, let's see. Where's my here's my find. Oh no, it's there. I mean, let's just look at this is the log file. So this is the log. Where is 10? I was like, you know, 6. There's 10. Oh, that's wave. Those are all the. Wait a second. Where's the WWV? Easy. Why hasn't it recorded any WWVs? Well, we can look at these. The burst offset isn't important. Less. That's a good create time. As long as the first one is right, then I can believe the others are due to
Yes.
clock jitter. Looks good to me. Looks good. I would say that let's treat this as a non-problem for right now. We got some WWVs. Let's see. We can do the head of each of those.
Yeah, everything looks like it's in second 0 as expected.
Yeah, just as we'd want. Okay.
But the second one's not, but that's okay because the second one is not synchronized to the clock.
Yeah. No, it's not. After that, it's, you know.
Yes.
No, as long as the first, as long as the first one's okay, then and you're not reporting any RTP errors, then we're in anyway, this is good. This is great. I say declare victory for now and wait until there's a reason to worry about this. Okay, Scott. Thanks for all your help.
Fun.
It was great. Well, I think the next thing we're going to turn our attention to is the server stuff, and I don't know that we need to drag you into that. So it's
understood. Thank you.
Okay, I'm going to try to. I think. I mean, if it interests you, you're welcome, of course. But it would, and I do think Elmer's expressed an interest in looking into the server operation. So, but boy, it's really good having him working on hardware, isn't it?
What was it? He said something about, this is just a hobby for him and all that, but gosh, I'm wishing that I had coworkers that took their work as seriously as he takes the hobby.
Well,
I mean, he's really putting it in.
Yeah,
I like what he said about he builds 3 of everything. When I order something special like surplus, I always try and get more than one because I think, if if I don't get it now, the Chinese will never sell me another rubidium atomic clock for $30 again. So I really
Yeah.
like that attitude. Yeah, he's done some impressive work in the last month alone. I
Yeah,
have noticed.
he's a great engineer and a really nice person, a good friend. So, okay, I need to go. Time for me to retire here. I've
73, man.
been,
See ya.
okay, 73. Thank you so much. Take care. And I guess I may be in control, in which case I will back out of this. Turn off this. Where is it? Leave. Okay, leave. Yeah.